Hey there, GeoFam. Last time we worked together, we were talking about properties of special parallelograms. Well, today we're going to talk about properties of a bunch of other quadrilaterals. Okay, we're going to talk about some kites. We're also going to talk about trapezoids and the different things that they bring to the table. Okay, so first of all, let's discuss some kites. Okay, so kites are quadrilaterals with no pairs of parallel sides. Okay, so that's the first thing. No pairs of parallel sides. So they are the far left branch of that flow chart on the front of your notes. In a kite, adjacent sides are congruent and opposite sides are not congruent, okay? The diagonals of a kite are perpendicular. Okay, so they intersect at a 90-degree angle, so you got this stuff going on in here. Not unlike a rhombus, but it's a kite. Furthermore, here's an interesting piece to this, okay? The major diagonal, which is the larger one, okay, so the major diagonal of a kite is a perpendicular bisector of the minor. So perpendicular bisector of the minor diagonal, which is the smaller one. So that means the longer diagonal cuts the smaller diagonal in half at a 90-degree angle. Okay? All right. Sorry. Also, one more additional little nugget of information, if you can squeeze this in there somewhere. The major diagonal. Okay, so the major diagonal is also an angle bisector. Okay, and this actually goes back to talking about altitudes and medians and stuff. But the big one, this major one here, has some special properties, namely that it splits these two angles in half. Okay, so this is all fun stuff we need to know about a kite. Okay, so let's use this information to figure out some stuff about some diagrams. Okay, so on the left here we have a kite, CPSK, and it tells us that angle PCR is 50 degrees. So that means this little guy right in here is 50 degrees in measure. So we got to find the other angles, CPR, RKC, all that other stuff. So I want you to remember that all of these angles in here are 90-degree angles. Those are all perpendicular. And we have a bunch of triangles in here, okay? So angle CPR is this guy right here. So angle CPR, well, you're in this little triangle down here. You're in this triangle right here. I have a 50-degree angle, a 90-degree angle. So that means angle CPR has to be 40 degrees. So that way 40 plus 50 plus 90 equals 180 degrees, okay? That all comes from your triangle angle sum theorem. Angle RKC. Now here's some fun stuff here. So this little angle there is 40 degrees. Now I'm going to highlight this larger triangle here and show you that I now have an isosceles triangle. So in this big pink triangle, I have an isosceles triangle here. If this angle is 40, so is that one. So RKC is also 40 degrees. Okay. Let's see. RCK is the next one, which is this guy right here. And as I mentioned just a moment ago, This major diagonal bisects the angles that it intersects, so that means RCK has to also be 50. It matches that purple 50 right there. And PRS has to be 90 degrees because it is the intersection of our diagonals inside of a kite. Okay. In my next example over here, again, I'm going to mark what I know. I got some right angles up in here. We have 7y plus 2 and 20x plus 11. I know that these two angles right here are congruent to one another because this big triangle up here is isosceles. Okay, so that means 20x plus 11 equals 7y plus 2. I can't get anywhere with that right now because I have an x and a y there. However, if I come over here to this triangle here, I know that all three of those interior angles add up to 90 degrees. So I can say that 5y plus 6 plus 7y plus 2 is, plus 90, I forgot about that, plus 90 has to equal 180 degrees. So I'm going to add up my like terms. So I'm going to get 12y plus, it looks like 96, nope, 98. Hold on one second. So it should be, let's see, 6 plus 2, that's a 98. So guys, as I'm doing this, I just realized that there is a little bit of a typo on this. If you could really quick, where it says 7y, we are actually, that plus 2 shouldn't be there. So just scratch that plus 2 out. Okay, we don't want that plus 2 there anymore. It wasn't supposed to be there. So I'm going to go ahead and just erase this part and redo this really quick. Sorry about that. Forgot about that typo, needed to be fixed. Back to the question. Anyway, 5y plus 6 plus 7y plus 90 has to equal 180 degrees. If I add everything up, I'm going to get 12y plus 96 is equal to 180. Subtract 96 on both sides. I get 12y equals 84. Divide by 12. Y is 7. Well, if y is 7, then that means I can replace this y in this blue equation with 7. So 20x plus 11 is equal to 7, well that's a 7, plus 2. So now I have 20x plus 11 is equal to 49, plus 2 is 51. Oh, wait, we forgot. Never mind, that 2's not there anymore. Psych, we got rid of the 2. It's going to equal 49. Sorry, remember we took the 2 off of there. That was a typo. That 2 shouldn't have been there. Forgot to take it off of my little formula here. So again, what I'm looking at is this angle is congruent to this angle because I have an isosceles triangle here. So 20x plus 11 equals 7y. Y is equal to 7. So substitute that in. Subtract 11. I get 20x is equal to 38. Yes, I know this is a decimal. That's okay. X is equal to 1.9. You might get decimals for these. It's not that big of a deal. Okay? Usually I'll let you know in advance to round to a specific decimal place, and that'll kind of be a giveaway. Okay, next one. I have another kite here. So it's giving us a little bit of information. We know that this little angle down here is 72 degrees. As I'm looking at this, I see a big isosceles triangle right here. I hope you guys are able to pick it out here. I have these sides are congruent, so that means this and this are congruent. So that means the measure of angle 1 is equal to 72 degrees. Cool. Angle 2 is a 90-degree angle. The measure of angle 2 is 90 because the diagonals of a kite are perpendicular to one another. And then last, I got to figure out angle number 3. So what I'm going to do is I'm going to look at this triangle right here in this greenish color. And I know that this angle here is a 90-degree angle. So that means the measure of angle 3 plus 90 plus 72 has to equal 180 degrees. So when I do a little bit of algebra, the measure of angle 3 is equal to 18 degrees. Okay, so we found all of those guys. Remember, what we're doing here is we are taking what we know and we're applying it to the diagram. And once we've got that diagram all filled in with all of its information, then we're using that to find what we're missing. Okay, in this next one, we do have a kite. So we are going to show here that we have this guy and this guy congruent, and these two guys are congruent as well. So you just set everything equal to each other and solve. And to be honest, you have two equations that both have an x variable that are both, quote, solvable. And if you solve either one of these, I end up getting x is 4. So it doesn't matter which one you solve, you can solve them both. Divide both sides by 6, so x is 4 for that one. Doesn't matter, you get 4 both directions. Doesn't matter which equation you use. Okay, so again, we're just using what we know about these figures. The good news for you guys is that you get to use your notes on this stuff. Okay, that's awesome, because now you have it all written out in front of you. You know what properties each figure has and doesn't have. That's pretty awesome for you guys. Okay, we're going to talk about trapezoids now. So we got properties of the trapezoids. So what do we know about trapezoids? Well, we know that they have one pair of parallel lines. That's it. That's all we really know. For a general trapezoid, that's what it does. It looks like that. You have your parallel lines. An isosceles trapezoid, very similar to an isosceles triangle. You do still have one pair of parallel lines. Now, the non-parallel sides are congruent. Okay, so you can mark these as having the same length. The base angles, just like in an isosceles triangle, the base angles of an isosceles trapezoid are congruent. Okay, that's awesome. That's really good to know. Also, the diagonals are congruent. Okay, so these guys are congruent as well. Okay, so here's another, in the red, you can see the diagram with the parallel markings and the congruent base angle markings. Okay, there you go, there you have it. Let's use this now. Okay, if WXYZ is a trapezoid, what can you conclude? So I'm looking at this picture over to the right. If it's just a regular old trapezoid, I know that segment or side XY is parallel to WZ. I know that for sure. Okay, if it's a trapezoid, that's what I know. If WXYZ is an isosceles trapezoid, what can you conclude? Well, I know still that XY is parallel to WZ, but I also know that angle X, or angle W is congruent to angle Z. That's good to know. I also know that angle X is congruent to angle Y, believe it or not. Okay? Yay, that's fun. Okay, so next stuff here, we got two little trapezoids going on here. Let's check them out. ABCD here. If ABD, the measure of angle ABD is 75 degrees, find CDB, well, and the measure of DCA. Okay, well, we know that these guys are congruent, right? So if ABD is 75, CDB, Actually, I think we're missing some markings on this one. Yeah, this is the one where my markings disappeared. This is an isosceles trapezoid. This should have the marks on it, okay? So should be marked that AB is congruent to CD as well, okay? All right, so then that means that ABD and CDB are congruent, so that guy is going to be 75 as well. And the measure of angle DCA, which would be this guy up here, remember we have parallel lines. The two angle BDC and angle DCA are same side interior angles. So the measure of angle DCA plus the measure of angle BDC have to equal 180 degrees because that's same side supplementary. Okay. So if the measure of angle D, I don't know why I'm giving those 4 letters. I don't need them. If the measure of angle D is 75 degrees, find the measure of angle C. That's not too terrible. It's 105 degrees. Okay, so we found all of our missing pieces there. And then in this last one here, it actually came with the appropriate markings this time. Imagine that. So let's mark what we know. Okay, so we know if I have an isosceles trapezoid, I have my isosceles markings right here and also right here. So that tells me that these two base angles are congruent. Excellent, awesome, wonderful. So I know that 3x plus 8 has to equal 12y minus 1. What I also know are these two angles here are supplementary. So that means they add up to 180 degrees. So 7x plus 2 plus 3x plus 8 is 180 degrees. My first problem on the left I cannot solve. I have 2 letters. However, the one on the right, I can combine my like terms, get 10x plus 10 is equal to 180. Subtract 10. So I get 10x equals 170. So that means x is 17. I can then substitute that back in. 3 times 17 plus 8 equals 12y minus 1. So I get 59 on the left is equal to 12y minus 1. Add 1. So I got 60 is equal to 12y, which means y is equal to 5. That's it. We got it. We are done, folks. That's it for today. Please be sure to complete and submit worksheet. Well, actually, you just need to complete worksheet 6.5 and look to Schoology for further instructions. Thanks, everybody. Have a great day. See you later. Bye.